Good day, this is Group 23 and we are presenting on gasification. Gasification is a thermochemical process that converts carbonaceous materials such as biomass, coal, or waste into a combustible gas. It involves reacting a feedstock with a controlled amount of oxygen and steam at high temperatures. So when we say a thermochemical process, will basically mean using heat to promote chemical transformations of biomass to produce energy. So in gasification, biomass is what becomes our feedstock. It's also fed into the reactor, broken down to form gases, and those gases are used for heat production and power generation. So in the stages of gasification, the feedstock is prepared. That is, the biomass is processed to remove impurities and to ensure that the sizes of the particles are consistent and that the moisture content is right. Now the feedstock is fed into a reactor where it's reacted with high temperature reactions of oxygen and steam. The syngas produced in the reactor is cleaned to remove impurities such as stardust and sulfur compounds. So when the feedstock is or has undergone the reactions with oxygen and steam, gases are produced. Those gases are called synthetic synthesis gases, also known as syngas. Okay, so syngas includes hydrogen, methane, carbon monoxide, and carbon dioxide. They are basically gases from non-fossil sources produced through pyrogasification. And pyrogasification is a thermochemical transformation process which consists in heating carbon-rich matter to obtain a synthesis gas. Yes. So after the syngas has been cleaned, it can now be used for power generation and heat production. The processes involved in gasification include drying, pyrolysis, combustion, cracking, and reduction. So in drying, we are removing moisture from the biomass, basically by heat. So it can be done directly, indirectly, or by solar means. So with directly, we mean the hot gases come in contact with the biomass to remove the moisture. Indirectly, we mean the hot gases are passed through heat exchangers to prevent direct contact with biomass. And then with solar energy, means as solar energy from the sun is used to heat the biomass up and is preferred because it's a cost-effective option. Pyrolysis, this is where heat of, of about 500 degrees Celsius is applied to the biomass for decomposition in the absence of oxygen. So the biomass undergoes decomposition, releasing volatile compounds, a mixture of gases such as carbon monoxide, methane and hydrogen, and bio oil. So since no oxygen is present, there will be no combustion in pyrolysis. So pyrolysis basically um, deconstructs the whole entire biomass so that it breaks down the polymers in it into simpler molecules and simpler forms. Now, combustion is an exothermic reaction where fuel reacts with an oxidizer, typically oxygen, releasing heat and light. So it involves a rapid chemical transformation where fewer molecules are broken down to simpler form. So after pyrolysis, where heat has been applied to cause decomposition of the um, biopolymer biopolymers in the biomass, combustion does it again to much more simpler forms for easier use. So the energy released after combustion is used to heat the gasifier to produce fuel gas. Now, cracking is also a process of breaking down large complex molecules such as tar into lighter gases by exposure to heat. So cracking causes the molecules that have been broken down by combustion to break down further into simpler molecules. So when they are broken down further into simpler forms, it is then that they are broken down into lighter gases by the exposure to heat. So when this happens, it makes it easier for the gas to be compatible with an internal combustion energy. So the decomposition um, pathway starts from pyrolysis and moves to combustion, then cracking. So it breaks it down further until the gases are released. And these gases must be compatible with the internal combustion engine. It, it also ensures proper combustion because complete combustion only occurs when combustible gas is thoroughly mixed with oxygen. So realize that combustion due to oxygen, so the cracking just makes it fine now by making the gases released from the decomposition process mixed thoroughly with the oxygen involved. So reduction is a process of stripping of oxygen atoms from the combustion product. Now combustion and reduction are basically each other's reverse processes and usually operate simultaneously in chemical processes in equilibrium forms. So they reoccur, they continually reoccur. So from this diagram, realize that the input was one of the syngases and then water vapor. So the syngas here was carbon dioxide. Now realize that after going through the red hot charcoal bed, which is a reduction system, its output was H2 gas and then CO. So realize that for both of the outputs, um, gases, for both of them, one atom of oxygen had been removed from the input gases, just as one atom of oxygen was removed from carbon dioxide to form carbon monoxide, and then one oxygen atom was moved from water vapor to form H2 gas. So now, gasification is primarily used to produce electricity from fossil fuels. So it's produced when the syngas is burnt in the gas turbine. So after the syngas, that is the carbon monoxide, the hydrogen, the methane, the carbon dioxide are got they are burnt in gas turbines to produce electricity. Now we also realize that from the earlier slides, bio oil and biochar were products from gasification. So biochar is basically for soil application and is used to improve soil nutrient availability, aeration in soil, and soil water filtration. Bio oil is also used for skin toning purposes and to hydrate dehydrated skin. The gases produced during gasification are also used in steel making, oil refining, medical applications, fertilizers, semiconductors, and the like. So gasification is basically environmentally friendly and is preferred more to pyrolysis. So gasification technology holds significant promise for the future And collaboration between industry, academia, and government is essential for advancing gasification technology. Thank you so much for your time. This is Group 20 once again, and we presented on gasification.